So, good afternoon, dear participant. Welcome to today's session on Geo Web Services, Geo Portal for Disaster Risk Reduction. My name is Harish Karnatak. I am heading a department on Geo Web Services, IT and Distance Learning at Indian Institute of Remote Sensing, ISRO Dehradun. So today I'll be briefing you about this concept of Geo Web Services, that is basically for sharing of data, that is a raster vector data or maybe sometimes non-structural data also in the public domain, and how you can use these Geo Web Services or APIs in your own application so that you can make a effective disaster management plan with the objective of disaster risk reduction. So I will start from the brief introduction on the internet technology. As you may be knowing that the origin of the internet technology reached back to research of 1960s commissioned by the United States government to build a robust, fault-tolerant and distributed computer network. And at that time, the objective was a messaging system between the two computers or two electronic devices, especially for their Department of Defense of the United States of America. And the funding of new US backbone by the National Science Foundation was initiated sometime in 1980, as well as the private funding of other commercial backbones led to a worldwide participation in the development of new networking technologies and the merger of many networks. So basically, the National Science Foundation has initiated to connect the different network together, network of computers. And the first time the commercialization of this internet was done sometime in 1990 time period. So by seeing that, we can see that this particular technology is not very old technology. In fact, last 30 years, the major developments, whatever are happening in this domain, are directly affecting our life. Today, we are using internet for various purposes, right from our communication purpose, our entertainment. We are using the internet for many commercial activities as well as taking the government or government services. Today, if you see the users of internet technology are shown here. This is a simple status what I could get from internet till December 2020. It says that about 5 billion people, over the third of the world human population, have used the services of the internet. Now, if you see the distribution of the users in the internet domain, it varies from the Africa to Asia, Europe, Latin America, Middle East, North America, and so on. And you can see here in this particular table that in Asia itself, around 62% people are having access to the internet technology. So last 30 years, we reached up to this level. And worldwide also, it says that around 64.2% people of the world are basically is having the access of this technology. Now, why I'm showing you this particular slide? Because now you see last 30 years, this technology, how it has grown. And today, we are expecting that in coming 5 or 10 year time, or maybe maximum of 5 years, I'm expecting that the majority of population of the world will have access to this particular technology. That means in future, what we are expecting that the majority of our computation capability as computation requirement will be met through this particular platform. So by keeping this thing in mind, the geospatial technology also has grown in these directions. We also start using the power of this internet in our GIS, that is called basically Geographical Information System. And as you may be knowing that, so GIS is one of the component on one of the example of the computer based systems, or where we have the backbone as a database system, where database management system like RDBMS, ORDBMS, and today we are also talking about the NoSQL kind of database. So here the backbone of this GIS is data. Here two type of data we handle here. One is called spatial data and second is called attribute data. Sometimes we also call this attribute data as a non-spatial data. In GIS, we integrate both spatial and non-spatial data together in a data management system. And in the database management system, when we integrate, when we organize this data, then we can write queries, we can analyze this data effectively. And in fact, if data is stored in a database management system, then we are basically able to develop the multi-user GIS applications. That is also known as a web application today. And here in the GIS, we also have the model management system where we can write the models basically for understanding the future scenarios, for understanding the trends, patterns on these particular data sets. And finally, these days, in these advanced technologies, we are also talking about the knowledge management system. What does it mean? So whatever data we extract from these database systems and whatever knowledge we collect from the field observations or whatever knowledge the experts are having, if we can integrate this as a system, as a knowledge management system, then our GIS can produce a better result, can produce a better scenarios for solving a specific problem related to our geography. For this purpose, we have today two kind of system in practice in GIS, that is called information system, and second is called decision support system. So information system is basically we basically take the raw data, raw facts, organize as a data, and process this data and convert as a information. But in case of decision making support system or decision making system, what we do, we also include the models. We also use our model, and these models can be mathematical models, it can be any kind of models. Also here, sometimes the probabilistic models, arithmetic models, and all these things we use here. And then we basically generate the scenarios. We also generate the patterns. We also try to understand the trends on this particular database. So this is the overall structure of GIS with respect to computation architecture. Now here, the major component in this particular system are a database servers where we store our databases as what I discussed just now, and second is our application server. So application server, you can see this is a core component here, and here we can design different processing techniques, we can design the algorithms, models, and so on, and then we develop the applications, and finally we produce this application to the user communities. To do these activities, we require a robust hardware, because here the data sizing, data types varies. For this, we can say that hardware also is one of the major component of geographical information system. Now, if I move this GIS, this particular GIS, what I was discussing in the internet platforms, then what will happen? In that case, we will call it as a network-based geo-information services. So network-based geo-information services will have this kind of computation architectures where we will keep our data or application into a GIS servers, and these GIS servers will be connected with the application or web server, and the other end, at the user end, the users will be accessing these GIS applications either through a web applications like a thin client applications or sometimes as a thick client applications. So here in this kind of scenarios, the users are basically sending a request to the web servers, and web server is transferring this request to GIS server. GIS server is basically taking data or information from database servers and processing this data and presenting this as a response to the users. And this kind of web client and server-based communication systems are being used in the network-based geoinformation system. And these days, you must have seen that in internet platforms, if you talk about the ISRO Bhuvan Geo portal, you talk about the ISRO Vedas portal, you talk about the Google Maps, Google Earth, what they are doing, they are basically maintaining the geospatial data in the server side, and finally they are giving these services to the users, where the user is not only able to access this data but also is able to process this data on the fly the way the user wants. So this kind of computation systems are emerging today, and in this case we have one important or interesting technology which we are practicing in this domain is called Web 2.0, and we integrate this Web 2.0 with GIS, which is also known as a Geo Web 2.0. So if you are coming from the computer or IT background, you may be knowing well about Web 2.0, but for other people, just I would like to mention here, so Web 2.0 is referred as interactive web application with public participation, which allows participatory information sharing, interoperability, user-centered design, and collaboration of the World Wide Web. So some technical terminology I use here, but in nutshell, how I can explain it, when you are using a social media, like your Twitters, like your Instagram, and like your Facebook, so what you are doing, you are basically customizing your page without hosting anything in your own servers. Somebody is hosting the servers, but they are permitting you to customize your web page as per your requirement. But in standard website, like website of IIRS, website of ISRO, you cannot do such customization as a users. So what is happening here? You are able to develop interactive web applications. That means users are able to interact with the web applications to meet their own requirement. So this kind of collaborations are possible by using the Web 2.0 technology. So when we say the collaboration, that means these collaborations are communication, two-way communications, so that lot of data can come from the user side, lot of data can come from the server side, but at the user end, at the application level, we can again modify, we can customize, we can process, and then we can change the data information as per our requirement. So here the Web 2.0 technology is playing a very, very important role for meeting the requirement of the users. So here, if you try to understand this technology a little bit more, so here what we use the technologies like Ajax, Open APIs, REST, or XML, XHTML, CSS, RSS, GeoRSS. These are the some standard terminologies. What does it mean? These terminologies are allowing us interaction between the applications and user. So what is happening here? If you use this technology in GIS, what you can do? We can use web as a platform. We can allow the participation in the applications. We can do the content syndications. We can develop the web services and so on. What does it mean? So web services and website, these are the two different things. What you have to understand, when I say that I can make available my data as a web service, that means my user can consume this data in his or her own web applications. When the user is accessing or consuming this data information in their own applications, that means user is able to modify the presentation part of this data in their own application. So here we'll be discussing more about this today. So content syndication, very interesting. You must be using some newspaper feed or some news channel feeds in your mobiles. What is happening? Without revisiting the web page of the news channels or newspaper, what is happening? You are able to get the latest news automatically into your mobiles. These are the content syndication. Automatically contents are getting synced, are getting updated. So then we have the participation. Already in social media, these days we are seeing that we can participate in the discussions. So two-way communication can happen. And finally, we can also use this by using this technology web as a platform. Platform for what? platform for many things, like to meeting my computation requirement, like a cloud computations. I can host the data. I can use the software as a service, platform as a service, network as a service. So finally, this web or internet as a platform, I can use it. For this, we have these technologies already. I discussed about it, and these technologies are basically objective is to allow the interactions with user and application. So in this technology, we use a very important computation architecture. It's called as a service-oriented architecture, or we call it as SO architectures. What does it mean? In this computation architectures, what is happening? There is something called service registry or service broker. So what we can do, the service providers will basically register their services into this service registry, and the consumer will search this data or service registry by using the metadata. The metadata is basically data about the data, and once the appropriate service is available, then the communication between the consumer and provider will be established, and then they can start using the services. So this is a simple example. Now, where we are using this particular architecture in our day-to-day life, I will simply give you the example of the online ticket booking system like Make My Trip, Yatra.com, and so on. What they are doing, they are basically consuming the services from different airlines. So what user is doing, user is basically searching the appropriate flight here in the service registry of the Make My Trip or Yatra.com or maybe XYZ, and then when they satisfy their requirement, then the booking will be done on the server of the particular airlines. So this kind of architecture already we are using. This architecture, we will see why I am discussing here, because in remote sensing or in GIS technology, this architecture is very, very useful, especially for the disaster management point of view, when we require a lot of data or information from multiple organizations at the time of disasters. How we can consume this data in real-time mode. That is very, very important. That's why I'm showing this architecture to you here, and you will be seeing that this service-oriented architecture is very, very useful or very, very powerful, especially for the disaster management point of view. Now you come to the next point, which is very important, especially for the GIS or geospatial domain, where the service-oriented architecture is extensively used for different activity of GIS. Here, there is a organization called Open Geospatial Consortium, or we also call it as a OGC. It is a non-profit organization where the more than 600 members are there. What this organization is doing, this organization is publishing the web service standard for geospatial data, like our vector data, raster data, our encoding methods. They are also publishing data for sensor web services and so on. So there are a number of service specifications published by OGC. Today, more than 50 such standards are available. For example, if you are publishing your vector data, then we are using service standard called WFS or Web Feature Services. When you are publishing your raster data, then we are using Web Coverage Services. And similarly, there are other important service standards like processing of this data, and also data discovery, data navigation services. We have the coordinate transformation services. So coordinate transformation services are like from one coordinate system to another coordinate system. For example, in GIS, suppose one data is available in the your LCC, another is like a UTM. So how this projection system can change? That is basically through the transformation services. Similarly, there are other standards also. Since time is very limited, our course is very short course, so I'm not going in the technical detail of all the service specifications of OGC, but you have to remember that. So whatever data you are accessing from different online geodata repositories or geoportal, their service standards or the service specifications are basically from the OGC. The Open Geospatial Consortium, as I told you, they developed a standard for geospatial web services, and their mission is a world in which everyone benefit the here. So now what we are discussing about the OGC standard, and these OGC standards are basically available as a open source standards. Here you can see example of this, some of the example of these standards. I just categorize into 5 major categories. One is a catalog service, processing services, encoding services, data services, portal services, and other services. Now, if we talk about the catalog services, the OGC catalog services are basically for developing the clearinghouse kind of applications where you can search the appropriate geospatial data in the internet platforms, like you have the CS code, CSW, ABRIM, and so on. And then processing services are basically example like on the fly how we can process the data. For example, if you are interested to develop the geospatial model or scientific model, and you can publish this model as a web processing service, and user can directly provide the input to this WPS and can get the output. So here, suppose if you are not using these processing services in the internet, then what you have to do, you have to develop the software for different operating system or different users, and then it is a very tedious job. But in case of WPS, you can share your algorithm, you can share your process on the fly to the users so that it can be executed at the server end and the result can be presented to the users. The typical example are WPS, coordinate transformation services, or we also call it the CTS. And here, basically, the interoperability is a key challenge, because suppose you are executing some process in the WPS and you want transfer or you want use this output as an input in the next service. In this kind of architectures, you have to implement the web service orchestration. So chaining of services are also possible to solve a complex scientific problem. The next category of the web the service specification from OGC is called encoding services. The encoding service examples are like GML, or we call the geographic markup language. CityGML, we have the GML simple feature, filter encoding, SLD, keyhole markup language of KML. Now the KML is also the standard of the OGC, where you can basically use this standard for 3D visualization of the geospatial data in Earth Explorer. So these encoding standards are also available. And then data services are, examples are like for vector data, for raster data. Suppose you want to publish your geospatial data as a data service, that means your user will able to use this service as a data layer, so that the user can use this data by accessing the simple URL. So no physical data transfer will be there. So in real time mode, you can consume these data services. Like for vector, we have the WFS. For the raster, we have the WCS. And for the sensor observation services or sensor data, we have a service called SOS. And the portal service is the next category, which is basically used for the geo-visualization purpose, like WMS and WMTS. These two are the most popular services, where basically we basically we can use this standard for vector as well as raster data. So when these data sets are available to as a WMS or WMTS, that means the final output is presented as a JPEG or PNG or any static image. So where no data processing, no computations are possible at the user end, only visualization purpose we can use it. Other services are like Geo XCML, GeoRSS, or OWS Common, and these are some additional services what OGC offers for different activities to the users. By adopting these service specifications, today many vendors or many service providers are basically providing a GIS servers. These GIS servers are capable of doing the mapping or visualizations, data services, data editing, geoprocessing services, catalog services and all. And here it is not necessary that every time all the server providers will be using the OGC standard. If somebody is using the open service specification, open standards, then they will be using these standards from OGC. Otherwise, many commercial companies are giving their own standard, but GIS servers are capable of mapping, visualization, data services, editing, and geoprocessing and so on. In background, in general, we basically store and manage our data as a relational database management system, or sometimes we also call it GeoRDBMS. GeoRDBMS is basically a relational database management system which is capable to store and manage the geospatial data, especially raster and vector data, so where the data types are available. Or we can say that if any database management system or RDBMS is having capability of object orientation, then we can use it as a GeoRDBMS also. And most of the time, when we publish these services, we use the XML standard for distributed computing purpose. So these XMLs are basically adopted as a standard. And in the later stage, the XMLs are also further modified as a geographical markup language, where we can define our own tags for the raster and vector data, and data is presented to the users. In addition to that, in GIS, when we use the collaborations, or during the discussion on the Web 2.0, I was talking about the collaborative mapping collaboration. So here in GIS, we use the collaborative mapping in the and data services. So in this kind of platforms, you are able to you can do online mapping activities, like you can digitize the features, you can create your attribute, you can create the geometries like point, line, polygons on top of the satellite imagery or any aerial imageries, and then you can start building your own data in the collaborations. So what is the advantage here? In the traditional mapping environments, we use this desktop platforms like single user environment, like your Quantum GIS, you have ArcGIS and so on. These are the single user GIS platforms. But when we use this multi-user GIS platform like WebGIS applications, then we can perform the mapping on the fly, where user can create, and we can involve hundreds, thousands of people together in the mapping activities. And here, another important technology which is very popular in geospatial tech domain is called mess-up architecture. And this is a typical example for the disaster management point of view, how this mess-up is basically integration of multiple data sources together and presenting a new application to the users like this. So here, data from the RDBMS, data from the different portals like ISRO Bhuvan, the OGC web services, Bing Map, Google Map, RGS server, and so on. Then we have the SQL-based GeoRDBMS database, local files. We can integrate all this together, and we can develop a new application for disaster management or any other similar applications. Now, if you take the example of the collaborative mappings, there is a project called OpenStreetMap.org, and this is one of the most popular open source product from where you can download a very high scale vector data as a point, line, and polygon geometry with the attribute. And here you can also contribute as a mapping person. You can contribute to map your own locality, and on the fly, all these features are available in the web browser environment itself. In addition to that, there are few more popular geoportals or web applications where a lot of data is available these days. Today I'll be discussing about these things, and I'll be telling you the important advantage or important feature of these portals, so that you can use these web services or web repositories in your own studies. If you start from the Google Map, you know that Google Map is one of the most popular online mapping platform, which is being used by most of the users these days. So the strength of Google is their global satellite imageries and maps, especially in 2D and 3D environment. They have data up to the street level, and this data they share by using the concept of API. They do not offer any web service, but they share the data as API. So if you use the application programming interface or API of Google, then you can consume these map services into your own application, and you can design and develop a new application at your end. Bing Map is another important website or on data repositories from Microsoft. What they provide the global satellite imageries and maps, especially roads and point of interest, similar to Google Maps, but they have their own advantages. They are basically they are having the rich road and point of interest information for the users. As I told you, OpenStreetMap.org, this website is very popular in the GIS domain. Most of the time, the researchers, scientists, or maybe students are using this data extensively in their studies. And here, the vector data for entire globe is available free of cost. In fact, suppose you are looking for road network of your city, so I will recommend you go to the OpenStreetMap.org and then you access and you can download it. And OpenStreet also have their own private cloud through which you can download the vector data as a save file format. Then Wikimapia is another crowdsourcing approach for tagging the ground informations. ISRO Bhuvan is a portal which was developed by Indian Space Research Organization. It is basically focusing on India. It has the rich contents and seamless availability of multi-temporal, multi-resolution satellite data for entire Indian regions, and it offers the thematic and disaster services to the users. So here, basically, it is an Indian product, and we are using the Indian sensors, Indian satellite sensors, to provide this service to the user community. Now, if you come to the commercial domain, we have the Map My India. I will say this is one of the very rich point of information. For detailed maps of India are available here, and they also have the beautiful APIs, mapping APIs, so that you can consume into your own applications. And recently we have signed a MOU, ISRO has signed a MOU with Map My India. Now we are trying to build a mapping platform, an indigenous Indian mapping platform for the country. And here the satellite data and other thematic maps are coming from our own servers, and Map My India is trying to build their own rich mapping contents for Indian territory. And then these are things are available as a freeware and also as a commercial mode. Indian National Special Data Infrastructure, or Indian NSDI, is an initiative from Department of Science and Technology. Under this initiative, the metadata catalog and policy documents are available for the users. Here, all the mapping agencies of India are basically registered, and they have provided the metadata to this particular service registry. So if you are interested to know which data is available with which organizations, so I would recommend you to go to the Indian NSDI and search for appropriate data so that you can use this data for your own project. Biodiversity Information System and Indian Bioresource Information Network, these are the two important geoportals or services from ISRO, hosted at Indian Institute of Remote Sensing, Dehradun. What we provide the biodiversity spatial viewers, data download utility, rich data contents on the plant biodiversity of India. We also have the rich data contents for Indian Bioresource Information System distributed databases. Here the bioresource data centers, or we call the bioresource information repositories, they are basically located in different parts of the country. They provide this data free of cost to this portal. India Water Resource Information System is an initiative of Department of Space and Central Water Commission. where the rich data contents for water resources of India are available, and this is the URL of this website. So surface water and groundwater information, if you are looking for it, then you please go to this website. Bharat Map is an initiative from National Informatics Center or Department of Electronics and Information Technology, Government of India. They have created a multi-layer GIS platform and they named it as Bharat Map. Very rich contents are available. They try to integrate the demographic data up to the village level. And again, I will say that it's freely available to the user community through this particular URL. If you talk about the disaster-specific geoportals, from where you can download or you can access a lot of APIs, lot of web services, just I compile these things. We'll discuss now in coming few slides. Now, I will start from the Pacific Disaster Center, or we call it the PDC. This is a URL of this website, and they provide the global coverage of the natural disasters. Multi-hazard warning and decision support tools are available in this particular site. Then we have the global disaster alerts and coordination system, or we call it the GDAX. This is the URL of the GDAX. What they provide the natural disasters, satellite and ground observation based disaster early warning alerts in the RSS and KML format. So you can subscribe this RSS into your applications so that the latest data will be automatically updated into your own applications. Then we have the global flood monitoring system, or we call it the GFMS. This is again a global coverage. It is an experimental system using real-time TRMM multi-satellite precipitation analysis, or TMPA, stream flow, surface water storage, inundation variables at 1 kilometer resolution, available from this particular website. Then Global Flood Detection System version 2. This particular repository provides the near real-time flood monitoring system using satellite data. And wherever any flood is reported, they try to acquire the satellite imagery from the open repositories. They analyze the data and present to the user immediately through these repositories. We have the Dartmouth Flood Observatory. This particular online repository provides the flood archive records from 1985 onward, and the information contains affected areas, number of people killed, the number of people displaced, the cost of damage, and the measure of magnitude of the flood are included for each flood event, and this is well documented, basically repositories, and the archive is updated on an ongoing basis, and new flood events are added immediately. And I will say that this is one of the good research or R&D activities going on, where especially if you are a student or a researcher, for your own modeling activities or understanding the disaster pattern, if you are interested, you can go to this particular repository and you can see how you can utilize this for your own studies. Natural disaster hazards. This particular online data repository is providing the multi-hazard information on various aspects such as frequency, loss of life, and economy, loss of economy, and other information through this repository. The seventh number I have listed, the Fire Information for Resource Management System, or it is popularly known as FIRMS. This is again initiative from the NASA, and what they do, they provide the daily forest fire alerts and advisory as a RSS feed, as a KML, as a SAFE file, by using the thermal sensor from MODIS, Terra and Aqua sensors, plus the same time they also provide visible infrared imaging radiometric suite, or we call it the IIRS data. And every day around 3 o'clock, they are updating these repositories, and you can see the forest fire information for entire globe. They are basically calling fire information, but more focus is on the forest fire. Another repository which is very popular is called as a USGS earthquake databases. You know that USGS is having a very strong sensor web network to monitor the earthquake. So here they provide the monitoring of the earthquake activities worldwide with its special informations. If you subscribe the RSS feed of the USGS earthquake database, so automatically you will be getting the alerts of all the earthquakes reported by their sensor networks. And here I can say every 15 minutes, this information or data is being updated. Then we have the next important repository called Global Seismic Hazard Map. And here under this activity, this is again a global coverage. They provide the natural disasters like graded seismic hazard risk data. So seismic hazard risk maps are available, although the very coarse resolution, but looks to be very quite interesting mapping products which can be used for scientific studies. Then we have the NOAA WDC historical tsunami databases, and this is again a global product. The spatial information on tsunami sources and run-up event are available here, and they are updating basically this information on a regular basis through the regional tsunami early warning centers. Like we have the Indian National Center for Ocean Information Service, or we call it IIRS, in India, which is set up in Hyderabad. They provide the near real-time tsunami information from Indian Tsunami Early Warning Center, or we call it the ITWEC. And it's India-specific alerts, but again, it is a part of the global network also. So if you are willing to get this data, it is available from this particular website. Modest fire detection data is basically a very specific fire alerts or active fire alerts and advisory system provided by NASA from the modest-based near real-time fire location using thermal band. They provide two kind of product. One is a process product and also an NRT product that is called near real-time products through this data repositories, so that you can use this data for your own scientific studies. You know that lightning is another important basically disasters what these days we are studying. So lightning and atmospheric electricity data sets are available through this particular repository called lightning.nsstc.nasa.gov. Under this, again, the variety of data on lightning activities such as average flashes per grid cells per year, and this information is available so that you can also generate the risk map of this lightning, because this is also a very, very critical disasters which need to be studied and the alerts need to be generated. And then we have the precipitations and applications viewer. Under this activity and these repositories, again, it is a natural disasters category, and they provide the global coverage of 30-minute interval updates on the probable location of landslide using landslide hazard assessment model for situational awareness. That is their objective. And this precipitation and the application viewer, it is a visualization system. I will not say it is a data repository for data download, but excellent visualization system, especially for the landslide hazard assessment. Then we have the another important online data repository called Precipitation Measurement Mission, or we call it the PMM. It is a precipitation data from the GPM and TRMM missions are available from the NASA, and in the near real-time mode, they keep on updating this information for the users. You can directly get this data from this data repositories. From India side, IMD, Indian Meteorological Department, also share a lot of data related to weather forecasts, early warning, and so on. Here they host the information on the meteorological observations. They warn against severe weather phenomena like snow, tropical cyclones, heavy rains, dust storm, and so on. All these data sets are available from IMD website. From the natural disaster hotspot repository, you can get the special data on the natural hazards with frequency and economic loss. In the CDEC, that is a socio-economic and data application centers. So what you can get, they provide 209 data sets for viewing and downloading on various themes like climate, health, populations, water hazard, mortality and economic loss for flood, cyclone, drought, landslide, earthquake, and volcanic hazard. So excellent repository. So what is the impact of these disasters in the socio-economic condition of a particular country? So the around 209 categories, under this category, these data sets are available. So if you are interested, you can visit this data repositories. Looks to be very interesting repositories. Then we have the same from the socio-economic and data applications hazard mapper. So this particular platform or online platforms enables user to rapidly get an idea of the population's land area, dams, and nuclear power plants that could be impacted by a natural event such as flood, earthquake, fires, and volcanic eruptions. So all these things they are studying, and they are basically identifying the possible zones or possible area which can be affected by a particular disaster. So this is a very, very interesting area where you can explore these repositories. Then if you come to the NASA is this EOSDIS. This particular thing is basically focusing on the visualization and download of global level multi-resolution satellite imageries. The data products are updated within 3 hours of observations and essentially showing the entire Earth as looked right now. It offers a variety of applications such as forest fire management, air quality measurements, and flood monitoring. So this is another interesting things. Especially for the scientists and researchers, I would say that if you are looking for the raw data for your own models, for your own studies, this particular repository will be very useful for you. Last 2-3 years, another important data repository which is known as a Sentinel-1 or 2 data repositories, which is getting very, very popular among the user communities, especially for the disaster managers. It is a open access repository for the Sentinel-1, Sentinel-2, and Sentinel-3 data products. In fact, I can tell you the Sentinel-2 is one of the finest resolution data which is available free of cost in internet domain. Every 10 days, they update this data. So 10 meter spatial resolution data you can download from this repository free of cost. Then we have the USGS Earth Explorer. You may be knowing it. It is one of the most popular online data repository in the geospatial domains. It is a warehouse and source of free and open access satellite data from different space EO missions. So basically, they share the data from the NASA, from ESA, from the ISRO, from JAXA, Chinese Space Agency. If you are looking for a single data repository where the data can be downloaded, so I will recommend you to go to this website and try to access these data repositories where a lot of data is available free of cost for the users. From ISRO, we have a very good data repository called Gateway to Indian Earth Observation. Also we known it as a Bhuvan Geoportal. This is a focus is on India. It addresses basically 6 natural disasters. If you're talking about the disaster point of view, Bhuvan provides services on the 6 natural disasters. These are cyclone, flood, landslide, earthquake, and forest fire. And what we do here under ISRO Disaster Management Support Program, whatever data and information we generate, we immediately publish into Bhuvan Geoportals so that for the public awareness or public knowledge. So directly you can access in the near real-time mode what is the impact of a particular disasters. We monitor these disasters through our own space infrastructure. These are from the polar orbit or geostationary orbit. In addition to that, we also have the international collaborations under international charters. So during disasters, whatever satellite imagery from other space agencies we are getting, immediately we analyze it and we make available to the user community through our Bhuvan Geoportal. So whenever you get some information about some disasters in the country under these 6 categories, I will recommend you to visit Bhuvan immediately so that the latest update you can get what is happening and what is the condition on the ground. From ISRO, we have another data repositories which is very, very important, very popular among the scientific communities, called the Meteorological and Oceanographic Satellite Data Archival Centers, or we call it the MOSDAC. This repository is hosted at Space Application Center, Ahmedabad. It is archive and disseminate data from the satellite like INSAT, Kalpana-1, and INSAT 3D and 3DR. These are the latest, the cloud profiler sensors are there. And from the Megatropic, OceanSat, Saralatica, we are hosting this data into this particular data repository called the MOSDAC. Again, free of cost to the user communities. So under these things, almost the near real time, I can say around every half an hour this information is updated, although the resolution is very coarse, but it's very interesting and important data for the scientific studies, especially for the modeling activities. The IMD is using this data for the advisories and alerts, especially for weather forecasts and all, and are available as a raw product from this MOSDEP data repository. These are some of the popular online geodata portals or geodata repositories what we thought of sharing with you. Otherwise, if you search in internet, you'll be getting hundreds of thousands of pages and you'll be getting confused. So in this course, what is our objective? To give you the basic idea about the popular geodata repositories from the internet, so that you can use for your own disaster specific study. Now come to the next part, is the tools and models available in the open domain for disaster analysis. Since data is available, tools are available, now you can start your study very easily. So I would like to mention few of the popular tools here, just I compile for you. So let us start. One of the popular tools is called Anuga. The URL of this tool is this one. Is a free and open source software having the capability to model the impact of the hydrological disasters such as flooding, storm surge, dam break, and tsunamis. Very popular model. Then we have the HACRAS. If you are coming from this water resource or hydrological background, you may be knowing about it. It is one of the most popular product or model, I can say, for the hydrologists, called the Hydrologic Engineering Center's River Analysis System. And this is a URL of this particular model. Is one of the widely used free open source software to model the hydraulics of water flow through natural rivers and other channels. It allows one-dimensional study flow, one and two-dimensional unsteady flow calculations, sediment and transport, mobile bed computations, and water temperatures, water quality modeling. Through this HACRAS model, you can do it. Then we have the SWMM, or we call it the EPA Stormwater Management Model. This is used extensively globally in planning, analysis, and design related to storm water runoff, combined and sanitary sewers in the urban areas. If you come to the CAPRA, which is a risk assessment model, and this program is an initiative that aims to strengthen the institutional capacity for accessing, understanding, and communicating disaster risk, with the ultimate goal of integrating disaster risk information into development, policy, and program. Next model or tools which is listed here is called HAJUS. It is a nationally applicable standardized methodology that contains a model for estimating potential losses from earthquake, flood, and hurricanes. Then we have the TAUDAM. This is a very interesting tools which consists of a suite of tools basically useful for conducting conditioning of the dam and the extraction analysis of hydrological information from dam. So if you want to understand the flow directions or maybe other things like for hydrological point of view, and these things you can slope aspect and all things you can extract very easily by using this TAUDAM suite of tools. Arc Hydro tool, it is basically on the commercial side, but available as a free of course. But to run this model, this particular model, you need the RGS license with you. But otherwise, this particular tool is freely available. The Arc Hydro tool set is a suite of tools which facilitate the creation of manipulation and display of Arc Hydro features and objects within the ArcGIS environment. The tools provide raster, vectors, and time series functionality, and many of them populate the attribute of Arc Hydro features. So then we have the GRADs, very interesting, and we are extensively using this grid analysis and display system. It's an interactive desktop tools that is used for easy access, manipulation, and visualization of earth science data. And GRADs has been implemented worldwide on a variety of commonly used operating system and is freely distributed over the internet. So what you can do, suppose you are getting some model output from the WRF or some other models. So what you can do as a net CDF format, suppose you can extract the meaningful information by using GRADs and then later stage you can automatically publish for your own applications. Then we have a Snap, that is a Sentinel application platforms. This is again a open source common architectures for ESA toolboxes, ideal for exploration of Earth observation data. And the Snap architecture is ideal for Earth observation processing and analysis purpose. So these are the some tools and models which are specific for disasters. But for GIS also we have some software tools for data analysis. All quickly I will list out here. Maybe this is not the part of the session, but I thought of including because it may be interesting for you. Like we have the Quantum GIS, we have the Saga, we have the GRASS, we have software called ILVIS, GBSIC, Map Window GIS, White Box Cat, UDIC, Geodata, and Landsat. So basically what I did here in this lecture, I try to compile the important source of data. I try to compile the important models and tools, especially for disasters. I also try to compile some important open source software product which can be used for your own studies. So we'll be sharing this as a content, our study material in e-class platforms, so that you can refer in future time also. So since time is very, very limited, so quickly I run through these contents. I hope it will be useful for you. Thank you very much. Thank you for your kind attentions. Now you can post your queries. I will try to take some of the questions for discussion purpose. Thank you very much.